before we get to the next type of square root question, we need to sort of remind ourselves of some little things from previous classes. So, what is the difference between a plus b squared and ab squared? Does that plus make a difference? It really does. So if we think about what does squaring mean, it means write it twice and multiply. So this is a plus b times a plus b, and we have to multiply that binomial, FOIL, whatever you want to call that. Whereas this one over here is just AB times AB, and there's no pluses. So this just ends up A squared B squared. So the whole like distribute the squared, which you should never do, it actually looks like it works here because both of the elements here need to be squared. Whereas over on the left-hand one where there's a plus, this is going to end up A squared plus AB plus AB plus B squared, which simplifies to A squared plus 2AB, because 1AB plus 1AB is 2AB plus B squared. So there is a very big difference between these two kinds of squaring. When you're squaring something with an addition, you have to write it twice and multiply, and it's a foiling and binomial. But when there is no addition, it's multiplication. You can square each individual item, and it works. Why is that important? Because the next thing we're going to do are really, really long, but it involves being able to understand the difference between 3 plus the square root of x plus 2 squared and 3 times the square root of x plus 2 squared. And what we just talked about will sort of help you see the difference here. So in both cases, we're going to write it twice and multiply. So 3 plus square root of x plus 2, 3 plus the square root of x plus 2. And then we're going to binomial multiply. Remember, insides multiply with insides, outsides multiply with outsides, but never multiply an inside with an outside. So binomial multiplication, we're going to get a 9 plus 3 square root of x plus 2 plus 3 square root of x plus 2 plus the square root of x plus 2 times itself, which is the square root of x plus 2 squared. Simplifying from here, we get 9. Okay, 3 square root of x plus 2 plus 3 square root of x plus 2 is 6 square root of x plus 2. And then the square root squareds gives us an x plus 2 that's left. And then to finish this off, we need to still collect like terms. Notice we've got an x by itself, and then the 2 and the 9 can go together. So the nicest way to write this as a final answer is bring the x to the front. 9 plus 2 is 11. And then we'll tag the little thing with the square root, the 6 times square root of x plus 2 on the end. So when we multiply this out, there's a lot of steps. It's really ugly. You got to keep track of all the pieces. And we get this kind of icky looking answer. Whereas over here with this one, if we write it twice and multiply, that's 3 square root of x plus 2 times 3 square root of x plus 2. There's no additions between any of these. It's times and times and times. So we get 3 squared, and the square root of x plus 2 times itself, or squared. So that gives us 9 times x plus 2 as a final answer, and we could distribute that 9 if we wanted to. So notice when there's a plus sign between the number and the radical, it's a mess. But when there's not a plus sign, you really just ended up squaring the 3 and squaring the x plus 2 and making sure that that x plus 2 stayed in parentheses. We're going to need that sort of thinking. It's going to show up in the middle of our next problems as